I want to apologize for my itchy, scratchy Darth Vader voice. Oh, it's so disgusting. Okay, let me go. Okay, hopefully you guys bear with me and give me kisses of love to overlook my horrible voice. Okay, so I can't even get the cap open. Oh my goodness. Okay, to begin, my video, today's video, is going to be about Newton's first law of motion. I'm going to be testing his theory. It's also known as or referred to as inertia. I'm going to test his theory by using some object. I don't know, I haven't decided. I'm very indecisive. I haven't decided what object I'm going to use, but basically I hope you all know that Newton's first law of motion is an object in motion stays in motion unless acted upon by an unbalanced force, or an object not in motion stays motionless, right? Okay, that only makes sense. Let's get started. But before we get started, we're gonna do some FBDs. And I'm quite sure a lot of you are wondering, what the heck is a FBD? Because when my physics teacher said FBD, I'm like, oh, what now? But basically, FBD is basically a FBD is a free body diagram. And you're like, okay, you just told me what the F and the B and D stands for, but what is it? A FBD is the magnitude and the direction of an object. So now you know what the heck an FBD is and what Newton's first law is. So let's get to it. We're gonna test Newton's theory, okay? His law, which we all know is accurate. Okay, I'm gonna apply force to the remote, just the ordinary Comcast remote, no strings, no nothing attached, just a regular remote. Right, so let me open it and push. Right? Basically, I know you guys said, well, wait a minute. Didn't Aaliyah just say that an object in motion stays in motion? That is correct, but don't forget about the second portion of that. Unless acted on by an unbalanced force, there's friction involved. Like, it's not just, that would be weird if you push something and it just constantly kept going and going. There's friction that's acting upon it. But let's get to the FBD of this. Okay guys, we reached the best part of the video. FBD time. Okay, who loves physics? Okay, so keep in mind, I'm not artistically inclined, so just give me a break. Take it for love. So I'm not gonna draw a remote, I'm gonna draw a smiley face. This smiley face is gonna take the place of our Comcast remote, remember? So basically, we have four forces that acted upon the remote. We have a normal force. F of n just means normal force. And then on this side, my bad, I have to make this arrow more longer than the other arrow that I'm going to explain shortly. F of A. And that's just force, that's just applied force. That was me pushing the remote, like what gave it the power to move. And then what kept it staying there, what we have here, is FG. Take a guess what FG stands for. Gravity. How fascinating. And this side, we're going to draw this arrow a bit shorter than applied. Because if these two are even, then, you know, it just wouldn't work. All right, so this is F because that's friction. That's what got the remote to actually stop. For you, that's for you guys who are like, but I thought Aaliyah said his first law was to an object in motion stays in motion. But like I said, acted upon an unbalanced force. Our buddy here, buddy friction, got it to stop. And applied friction was Aaliyah pushing it. What can we conclude with? That Newton's a pretty intelligent guy and knew what he was talking about. We just did an experiment with, I call it the push remote theory, the push remote experiment, and it worked. So basically, I'm gonna wrap up this video with a quick conclusion, because I know you guys are sick of hearing my annoying voice, because I know I'm sick of hearing this irritating, scratching voice. It literally felt like a cat jumped inside my throat and scratched it. So yeah. But basically, normal force, applied gravity, and friction. That's how you guys got the remote. That's how the remote stopped. Okay, we're going to conclude that, like I said, Newton was a pretty smart guy that created this stuff. He knows what he's talking about. So yeah. No, but on a serious note, we can conclude that Newton's first law of motion is correct. An object in motion stays in motion unless acted upon by unbalanced force, and a motion not in motion stays not in motion. Also known as what? Inertia. And you guys know that a FBD is a free body diagram. And you guys know what each arrow stands for. Just a quick tip, additional information. This F of A could change. This F of N, Fn could change, being F air, which is air resistance. But we're not gonna worry about that right now because it's a whole different topic, and I'm not a physics teacher. So yeah, see you guys next time. You know, bye. I heard you guys talked about the north. Basically, the direction. Okay, I don't remember what an FBD is. That's pretty bad, and that's what this video is about. You guys are annoyed with hearing my ugly voice because I'm ignored. Wait a minute. I don't even know what I just said. Jesus, my voice sounds really disgusting.